Okay, welcome everybody. Thank you so much for taking time out of your Thursday to spend a little time with a couple of other authors and instructors for exploring open content and adaptive technology. And my name is Eric Stano. I'm the Senior Director of Content with Newton. I will be moderating today with the help of my colleague, Bridget Rivera. We'll start off by listening to our author, Jay Abramson from Arizona State University, talking about his college algebra text through OpenStax that has partnered with Newton. We'll segue from Jay to myself, where I will talk about what that partnership looks like. And finally, we'll land with Andrew Moore from National Louis University, who has been using the OpenStax content in a Newton context, and he'll be describing his experience with that. So without further ado, actually with a little further ado, just note that your line is muted by default. You can absolutely and are encouraged to use the raise the hand feature available through the control panel on the right to ask questions. You can write those questions at any time, entering them into the questions section of the control panel. And following this meeting, you can request the slides and a recording of the webinar by mailing highered@newton.com. So I believe that's the end of my preamble. So with that, I will hand it over to Jay.
Good morning, and thank you for attending. Let's see, can you see my screen now?
Yes, we can, Jay.
Fantastic. My name is Jay Abramson. I'm the lead author of the pre-calculus text, and from the pre-calculus text, we derived the college algebra text that we're going to talk about today. I'm a principal lecturer here at Arizona State University, and I'm going to talk to you today a little bit about the book development process, highlights of the book, and touch on teaching with the book and how the book may align with some current trends here at ASU. As far as the book development process is concerned, a few years back, Anthony Palmiato and myself, and he's the editorial director at OpenStax, we discussed a viable alternative to current pre-calculus texts that were out there. And remember, from the pre-calculus text, we did derive the college algebra text. So it turned out we shared some common goals. We both wanted a book that would be competitive with the current mainstream titles out there, and it was a book that would cover more than any one semester offering could cover. We wanted it comprehensive, inclusive of college algebra content, trigonometry, analytic geometry, sequences, probability, other advanced pre-calc concepts, counting theory, parametric equations, systems, and so on. And he said he'd support me with a great deal of editors and reviewers and co-authors, and we'll talk about that here in a few minutes. And OpenStax has the text free to students. And we wanted to deliver this text so that it was every bit as sound in content and rigor as the mainstream titles that were out there. The slide you see before you is placed so that we can mention that we did start the work with a derivative of pre-calculus and investigative of functions by Lippmann and Rasmussen. And this tree in front of you is actually a clip from the book. I've been teaching some 34 years, and students seem to ask everything over the course of that time. And once I was just talking about how to measure the height of a tree, and the student said, well, why don't you just climb the tree and drop a really long tape measure down? And so I included that in the book, with the point being, all throughout the writing process, we did keep the student in mind how they react to different concepts. Now, as far as the book development process, the vision of it, again, we wanted to write a mainstream pre-calculus text that included any topic that could be included. So from the pre-calculus, we created a second text, college algebra, which is what we're talking about today. And the topics we have are functions. We have a chapter dedicated to linear functions, polynomial functions, rational functions, exponential and logarithm functions. We have the enhanced college algebra topics, like linear and nonlinear systems, sequences, series, probability, counting theory, vectors, partial fractions, matrices, and so on. And again, the result is this college algebra text really covers any material that probably a school would want to deliver, certainly there's enough material to cover a 2-semester course if needed. Now, this was a collaborative effort. I was the lead author, so I developed a table of contents. I developed the learning objectives. There was 458 of them in the pre-calculus text. I wrote a few of the chapters. I reviewed literally everything, but I had an enormous level of support. And what I want you to take away from this is that this was a collaborative effort by a group of dedicated authors and editors, instructors, reviewers, and we drew on talents of many to try to provide a comprehensive text unified in purpose and voice. And to do this, we needed a lot more than many authors. So great pains were taken to ensure the validity and accuracy. Each chapter manuscript underwent at least 2 rounds of review. A separate team of experts checked all the text, examples, and so on. There were multiple reviewers assigned to each chapter. A third team of experts was responsible for the accuracy of the answer key. We have links in the book so that if you do see any errors or if you have any suggestions, you can click on the link and those revisions can be handled very quickly. And when you have this many people involved in an endeavor, the goal is tricky because you want the final product to really have one voice in its final form. And this was ensured by one phenomenal editor who I wanted to give a shout out to, and her name is Christine Caputo. Now, the book itself is set up so that at the end of the section, obviously you have section exercises. What you see before you is the section exercises, the topics, and roughly the number of questions per category, and this would obviously change from section to section. But we try to create 5 verbal questions that assess conceptual understanding, and heavy dose of algebraic problems, 60 of them we strove for, and that was going to focus on algebraic manipulations. We wanted 10 graphical problems per section, and obviously this would be specific to certain sections when you're looking at things like transformation of functions or parametric equations. Then obviously those numbers would go way up. We tried to have at least 10 numeric problems that required the student to perform calculations. We had a technology section, again, roughly 10 questions with explorations. And we always had extensions and real-world applications, trying to go for a combination of about 30 from those 2 topics. And we try to pull from physics, geology, biology, finance, a broad range of the disciplines so that we were fully aware of many different disciplines are going to need to be covered for the cohort that goes through this particular course. As far as teaching with the book, just kind of the basics, we did use the rule of 4 approach, tying together verbal, algebraic, numerical, and graphical. We emphasized multiple approaches to a problem. You know, here's the algebra, here's the graph, and we had analysis features where we went ahead and discussed the relationship between the 2. We discussed the use of technology where appropriate, and we stressed verbalization skills. Had the students actually answer verbal exercises, included question and answer features. And again, we felt we had ample section exercises and review exercises for the student. At ASU, I've been teaching a hybrid flipped classroom for business calc for about 5 years. I developed videos, developed PowerPoints. And the reason why I mention that is when we wrote the book, we were really trying to write the book so that it would be able to be used in different formats, traditional, hybrid, online, flipped. So painstaking care was taken to make sure we had, for example, the learning objectives up front, the section exercises tied very carefully to the learning objectives, make the book readable for the students. At ASU, if I may, talk a little bit about at ASU. ASU was ranked #1 in innovation by US News and Reports. They have what's called a Global Freshman Academy. where they have these MOOC classes. And so for the Global Freshman Academy, it's big, it's huge. We have over 230,000 students from 180 countries enrolled in these GFA courses. These courses are the same courses that we deliver traditionally, same faculty teaching them, same credit. And for the college algebra course, they adopted this OpenStax college algebra book. I was not involved with that decision. And I think partially because it lended itself very well to the online format. Lastly, as we wrote it, we do realize that there are nationwide trends in college algebra, two very opposing ones, as a matter of fact, the technique-driven curriculum versus, the modeling approach. And we tried to have a balance between the two with enough quantitative reasoning type problems in the exercises and in the examples. And again, we were pretty heavy with the algebraic skills that they would need. Thank you, and if I can entertain any questions now or later, I'd be happy to.
Again, hello everybody. I'm Eric Stano. I'm sort of the bridge between the two fine panelists that agreed to join us today. I'm the Senior Director of Content at Newton, and Jay has just given you some insights into the rigor of the process through which he went to develop his textbook with OpenStax. He talked a little bit about what makes that textbook distinct and special and hopefully usable by some folks on the line. The reason I'm here and partnered with Jay is that Newton is offering this content through our platform. So there's a partnership between OpenStax and Newton so that you can get the quality of content that Jay has developed through our mastery-based adaptive platform. So let me begin talking about that. Some of the key course challenges that Newton has been targeting, as well as Jay himself, but really our raison d'etre is around the fact that students are not reading or studying or doing their homework outside of class. There's obviously a sort of a pandemic of low exam scores and poor performance. We recognize that you as instructors are facing, particularly with redesign these days, varied levels of preparedness in your classroom, so just a wide spectrum of students who are ready to do college level work. And we're also looking to lessen the expense pretty dramatically of learning material. The impact we've had thus far, we're a young company, but we've already seen a lot of data. The N is still a little bit low, but persuasive directionally, that we can improve pass and retention rates without lowering standards, where we're trying to close the gaps in readiness. I just came from a conference where we talked a lot about equity, and we want to make sure that all students have the opportunity to succeed and persist. We want to challenge using our adaptive platform and Jay's fine material. We want to challenge the best students and majors while aiding and providing interventions for those struggling students. And again, as I mentioned above, I didn't realize the redundancy in my own slide. Yeah, we want to bring the cost of course materials down precipitously. So what is Newton? If you were to adopt Newton's college algebra course and avail yourself of Jay's course materials, what would that be like? That would be in the context of a mastery-based, personalized learning experience for your students with data-driven recommendations that are provided to them. I'll talk a little bit more about that. My role as the Senior Director of Content is to oversee a group of content developers who rigorously develop, curate, and calibrate the OER content. Jay's content is the OER content in this context. And what my team does after developing a set of learning objectives based on curricula that are out there is ensure that each morsel of Jay's content is driving toward a particular learning objective to ensure mastery of that learning objective. Newton provides a fluid interactive experience which interweaves OpenStax, authors, Jay in this case, peer-reviewed, commissioned, peer-reviewed content We also commission unique assessments, and again, we're precisely aligning those with the course objectives. And full disclosure, I was at Pearson for 20 years, and I know well how not simple it is to provide a simple, interactive, fluid experience. And that's what your students and you would experience using J's content within Newton. Side note, something that differentiates Newton from other platforms that may be talking about adaptivity is that we provide cross-discipline recommendations, a feature called booster assignments. So if a student is flagging on a particular item or particular learning objective, and it's related to some cross-disciplinary area where they don't have mastery or they've lost mastery of it, we're able to provide that. A good example is in chemistry here. If somebody's tripping over a chemistry learning objective, we're able to provide them with math. We're able to do the same in math across a wide spectrum of objectives and items. We have precise predictive capabilities, so we're able to tell within a couple of weeks of students interacting with the platform whether they're going to or whether they're in peril of actually not passing their midterm, and we're able to give you, the instructor, actionable intel on that, but we're able to tell with relatively few interactions with our platform how that student's going to perform when it comes time for a high stakes assessment. And again, I said we're a young platform, but we've already seen very persuasive results in the impact of our adaptivity. Now, I sort of alluded to this briefly. You've probably heard a lot about personalization, adaptive systems, etc. This is a graphic that sort of represents, and I can speak from experience having been at a traditional publisher, this represents what adaptivity is considered in many of the traditional publishers. It's a predetermined pathway. There's a finite number of them. If you do X, you get Y. If you flag on Y, you go back to B. It's a very set pool of pathways that you can go down. Whereas at Newton, what you're able to, and there goes my sorry, I think I just lost my slides. I'll get them right back. There we go. Here we go. Whereas at Newton, we have the concept of a knowledge graph, and hopefully you're able to see this video. The knowledge graph is established to understand that there's no real predetermined pathway for individual students. Every student's experience is their own. And this is an example of an actual class and actual students moving through our various learning objectives, moving through our various modules of content. My team thinks a lot about the prerequisites, so if a student flags in a certain area, we're able to understand where and how they're flagging. Again, there's no predetermined pathways for the student. We're reading the data on how that student's performing or not, and providing them with the appropriate interventions at all time in order to ensure that we achieve mastery. So that's really the special sauce of Newton, and again, the experience of J's content within it, is that a student does not have a predetermined pathway, that we're understanding the data that the student's providing by virtue of their interactions, where they're being successful, where they're not, what they need in order to achieve mastery of a particular objective. An additional piece of the Newton special sauce is the fact that these are, one, data-driven recommendations. We can understand what that student is struggling with or not, but we also provide an evergreen experience. We have an in-house data science team that is, and there's no hyperbole here, on a daily basis reading the effectiveness of Newton's instructional assessment content, and we iterate based on that. I've literally stood in or sat in meetings where we look at an item, we say, okay, 70% of students are flagging on that item, something's amiss there, and we're able to adjust it. This gets us away from something you're very used to, the idea of additions every 3 to 4 years. a new edition is out and you need to revise what it is you're doing relative to that edition. That doesn't exist within Newton. We are iterating on a daily basis to ensure that your students are achieving the very best outcomes. And we're not only reading the data we collect just by the nature of the way we're set up, we're also iterating based on the feedback we receive directly from students who offer us their feedback. There's a feedback button on every page of the Newton platform. So if they're reading Jay's content and don't quite understand it, we're able to actually look at that and adjust relative to that. If an assessment item, they perceive that they got a right answer, but it wasn't quite right, we're able to respond to that. So again, this provides an ongoing improvement effort to achieve the optimal outcomes. And just Jay talked a lot about the rigor of the process through which his content went to be ready for prime time. This is just an example. And again, we always hear about OER that it hasn't been rigorously developed. Not only has Jay's content been rigorously developed to bring it to the water's edge once it wades into Newton, what it undergoes is a very rigorous process, again, of developing learning objectives, curating his content and our other OER content, which is in terms of instruction is the videos, the assessment creation. It's all driving very much towards ensuring that students have the material they need and the assessments they need, the feedback they need to achieve the objectives that are there and achieve mastery ultimately. So with that, I will turn it over to my next colleague.
So my name is Andrew Moore. I'm an assistant professor and the math content lead here at National Louis. And we began using Newton last year and have continued using it. So I'm going to talk a little bit first about why we chose to adopt Newton. So in the fall of last year, I was asked to look into finding a way to build math acceleration into our student seminar course, but it needed to be simple enough that our non-math instructors could guide students through the software as well. I experimented with a few different softwares, including Pearson's My Math Lab, Alex, Acrobatic, and finally Newton. Newton was a courseware that, which to me met our needs the best. It was adaptive to the student's needs, offered engaging instruction when the student was struggling to progress, and the content was of a very high quality. I also found the support I received from the Newton team to be very supportive, and an entire team of staff members actually came out to help us get started last year. So the challenges that we were trying to address with this software was our students are coming in with a large educational debt. Many of their math skills are not college ready when they get to our program, and we do not offer any developmental or 0 credit hour math courses. So we needed a courseware solution that could be built into our weekly seminar course, but would not require the non-math instructors running those courses to provide actual math instruction that they weren't comfortable with. And so when we were building this acceleration course, we actually only had one full-time math instructor, myself, working with about 350 students. And so when we first started it, the way that we were implementing it was for the winter and spring quarters of last school year. We had it set up where it was an optional portion of the seminar for students. They had 3 different options which they could choose from. They had a math option, a writing option, and then individual tutoring as an option. So we left it very self-directed and open for our students to work. And from that time period, what we found was the students who engaged with the Newton courseware at least once had an average grade of 71% versus a 69% for the students who did not get into the courseware at all. And this is for our Math 101, our college algebra / quantitative reasoning course that those grades come from. Starting this quarter that we're currently in our second week of, it is now an automatic thing that our students that are enrolled in math courses will be using. And in fact, this week they had their first experience with using the Newton in the new way that we've implemented it into the seminar And we've already had a few students come to us and mention that after having completed the Newton assignment for this week, they felt much better about the material. We teach in a flip model, and so they had already done their reading, already gone through class, and then finally got the Newton as a third exposure. And many of the students I've spoken to have said that the Newton software really answered all the questions that they had left over moving into this week's homework. So just some of the data that has to do with what we've been using. So in the first month that we used the software, we had 69 students use the software at least once. They completed 178 lessons. They completed 2,929 questions, and they had 259 additional instruction videos or lessons that they viewed while they were working on the software. In fact, we actually pulled another piece of data recently from that time period and found out in that 1 month, our students actually spent a little over 4,000 minutes in the software during that 1 month. So there's a lot of questions that they worked on, and they spent a lot of time in there really working to master their skills. And one of the things that's really impressed all of us here has been the depth of the adaptive nature of this software. We are working inside of a college algebra course looking at plotting Cartesian points. And as we were working in the assignment, we kept missing questions intentionally. And the software actually backed us all the way out to a pre-algebra lesson on absolute value and the differences between positive and negative numbers, because the software realized that we were constantly plotting points as if we didn't understand negative numbers. So it took us back all the way to that level. And then after the lesson, when we started getting the questions correctly again, it jumped us back up to an appropriate level very quickly. So just a little bit of advice for any of you that are considering adopting an adaptive courseware. For us, the most important thing that we said was it needed to meet both our students' needs, but also our instructors' needs. So we do suggest to try multiple softwares and see what works best for you. For us, the Newton software was what we found worked the best. It gave our students the most flexibility in getting the support that they needed as they were working on the courseware at home. And it also gave our instructors a lot of data to work with. They can see how a student's progressing through an assignment or see how an entire class is progressing through an assignment, and really get a lot of student performance metrics that we found helpful in providing additional instruction to students who struggle to progress through the courseware on their own. We really like that the Newton software is just not only adaptive, it's also individualized. So you can't have two students sitting next to each other working on the same lesson and having the exact same questions at the same time and just, working off of each other side by side. And one student doing all the work. So we really like that it was individualized like that. So our students really have to do the work and do their own work and progress. And the goal level of mastery for all of our students has been really interesting, letting them know like the more questions that you get correctly, the less work you will have to do, and seeing our students really responding to giving every question a lot of value, because they know if they miss this one question, it'll probably add 2 to 3 questions onto the amount of questions it'll take to complete the assignment. So that's all I had about our use of the courseware, and I'm going to give it back to Eric to open it up for any questions you have for me or Jay or Eric. So thank you very much.
One minute. This is Bridget while I get access here. So we had one question come in, and the question was, what is the cost to students or institutions for Newton? That's the first question. And the cost to students is $40 for 2 years of access. They could also buy access on a monthly subscription basis directly from us for $9.95 a month. So there's and of course they can purchase Newton also from their bookstores. The other question that came in is there any special technology needed by our institution, and is it compatible with Blackboard? No, Newton is web-based, so it's a web-based program. Your students would access it online, and it is compatible with Blackboard, and it's also compatible, another question we got is if it's compatible with Canvas, and it is also compatible with Canvas. It's basically compatible with any LMS.
We've been using D2L at my institute and had no problem with Newton integration.
Thank you, Andrew. Eric, over to you.
There we go. I was muted for a second. So I wanted to thank everybody and actually just underscore something that Jay had said. Again, the point of this program, it really is differentiated from other digital platforms that you might have used where a student might get 20 discrete items. They perform well on some, poorly on others. We hope they study up on the others to really grasp the skills and the concept. Newton being a fully adaptive platform, it's elastic in nature. So if it determines that a student is struggling, it's going to begin to give them additional content, additional practice, oftentimes on prerequisites that are undergirding the skill that they're working on. So the advice that Andrew offered is absolutely correct. You know, we always advise students don't guess, because if you guess and you start getting things wrong, you're going to spend more time in the platform, because the very raison d'etre of the platform is to ensure that students are achieving mastery. So with that, I will thank Jay and Andrew both for joining us today. I'll thank all of you for spending what I know is a busy part of your day. If you have any questions or would like to get, again, the slides or recording of this session, you can contact us at highered@newton.com. Also, if you are going to a Matic, please let us know, and you can let us know that at highered@newton.com. And with that, again, I'll thank you for your time. Hopefully you found this instructive and useful, and please get in touch and ask any other additional questions that you might have.